Okay, today we have solving right triangles. And this is section 5.8. Okay, now numbers 1 to 10 we have today. This diagram is given and it applies to all of the triangles for today's activities. That's point C, B, and A. And in right triangles, well, in all triangles, the side opposite the angle is labeled with a lowercase letter. And generally speaking, if there is a right triangle, it's labeled C in triangle ABC, but it doesn't have to be. Okay, and what we're given for today is, for each triangle, you're given two of the dimensions. Okay, so for triangle 1, we're given angle A is 23.5 degrees and side B is 10. And of course, you know angle C is given as a 90-degree angle. So you're asked to find the other three unknown parts of the triangle. Okay. Now, since you're given one angle, the second angle is very easy to find because all three angles in a right triangle have to add up 180 degrees, and this one is 90. So these two, and this is true for all right triangles, the two acute angles have to be complementary. That's the fancy way of saying they have to add up to 90 degrees. So all you have to do to find angle B is subtract 90 minus 23.5 degrees, and that will give you 66.5 degrees. That's one of your three answers that you need. Okay, now we also need to find the sides that we don't know. We only know one of them. Now we're going to have to use trigonometric methods to do that. So we could find either side C or side A based off of side B. Let's find C first. Okay, now when you're doing solving right triangles, you have to look at what you have and what you're looking for. Okay, so we have either of these two angles and that side. Okay, now A was given, so we usually work off of the given information. So we have angle A and the side that is adjacent to it. Now remember, in a right triangle, you can label the sides either opposite or adjacent, but that depends on the angle that you're looking at. You know, we're using SOHCAHTOA here for right triangle trigonometry. So we have angle A and the side that is adjacent to it. That would be side B. Okay, and we're looking for side C. All right, so we can say that the cosine, because it's adjacent, of angle A is equal to the adjacent side B divided by hypotenuse C. Now, we're looking for side C, so we have to isolate this equation for side C. So, and to do that, first thing I do is cross multiply. So this can be thought of as being over 1. You don't have to write that though. So I have C times cosine A is equal to B. Now I find C by dividing B by cosine A. Isolate. Now I think that it's best to write this, and don't put the numbers in there until you're ready to calculate. Okay, so I'll calculate. Now, the first thing we do is check the mode, because we have been working in radian and degree, but triangle problems are always done in degrees. Okay, so we're in degree mode, and B is given as 10, and we divide that by the cosine of 23.5. And there we have it. So C is 10.9. approximately, and we're going to the nearest tenth of a degree and a tenth of a unit. Those are the rounding parameters. All right, now we could have gone with a different technique. We could have used the sine of angle B, and side B is opposite that angle, so we could have said sine of angle B is equal to opposite divided by hypotenuse B over C. Now, I mean, these two things look different, but So then I can, again, cross multiply C sine B. But I mean, I say they look different, but they are different, but you're doing basically the same thing. You're calculating the same thing, and this is a good way to check your work to make sure that you've actually done it correctly. Is that if you can get the answer more than one way, it's better to get the answer more than one way. All right, so C times the sine of B is equal to B. Now remember, we're looking for C, so we're going to divide B by the sine of B, and we will calculate. I'll move this up a little bit to make sure I'm on screen. Okay. All right, given information, we've got B is 10, and this time we're going to divide by the sine of angle B this time, but we had already calculated angle B to be 66.5 degrees. And there we have it. You should always get the same answer, and see, that's a good thing about doing, I should move that out of there, is that doing right triangle trigonometry, there's almost always a way to check to see if what you did was the right thing. And if you get the same answer twice, you're probably doing it correctly. It could be a coincidence, but that's highly unlikely. All right, now we're down to side A. We found angle B and side C, even though we did it two different ways. You don't have to do it two different ways, but I'm just showing that you can do it two different ways. Now we're going to find side A. Now we can do this a couple different ways. First of all, we know sides B and C, so by the Pythagorean theorem, we know that A squared plus B squared is equal to C squared. And we do not know side A at this point, so I can isolate A squared is equal to C squared minus B squared. That makes A the square root of C squared minus B squared. Move this up so we can see this. Now I suggest doing this all at the same time. We're going to take the square root of C squared, which is 10.9 squared, minus B squared, which is, what was that, 10 squared. And that will give me about 4.3. Okay, now we could have done that a different way. We could also recognize, going back to the diagram, if I can find my frame, there we are, that we were given angle A. We already know angle B as well, and we can use the tangent ratio because tangent is opposite over adjacent. Again, go back to what you know and what you're looking for. All right, if you know an angle and the adjacent side to that angle, you can find the opposite by using the tangent ratio. Okay, so we'll go with angle A. We could write this, that the tan of angle A is equal to side A divided by B. I should leave that in frame, and I will. Tan A is equal to opposite over adjacent. I could also write this as well. Tan B is equal to B over A, and that would be right. And we could use either of these ratios to solve the triangle. Now, since we're looking in this, we're looking for A, if I cross multiply this one, remember I can think of this as a fraction, B is equal to A, or pardon me, A is equal to, we'll leave it over here, B times tan A. So all I have to do then is multiply B times tan A on my grapher. I'll put that right here. You can see it. Yeah, it's in there. Okay, so I know that B was given me as 10 times the tan of angle A, which was given as 23.5, 4.3. Now this doesn't come out to be exactly equal to that one in this instance because we use a rounded value over here for the calculation. Now this was all given information. So and it's probably best if you're solving any kind of problem. To tell you the truth, it's always best to use given information if possible. Okay, one more example, and that would be number 7. Okay, oops. Okay, I'm ready. All right, and this time we're given A is equal to 30.4 and C is equal to 50.2. Okay, and keep in mind this has the same diagram. Point C, point A, darn it. B, there's an A, C, and a B. Okay, now if you're given two sides of the right triangle, really the first thing you should do is find the third side by Pythagorean theorem. A squared plus B squared is equal to C squared. Since we know C and A, we isolate for B. B squared is equal to C squared minus A squared. And I talked about how to do that before. I do it all at the same time, and I think you should. So we take the square root of 50.2 squared and subtract away 30.4 squared. We get 39.9 to the nearest tenth. Okay, now we can find angles A and B. Now we don't know either of the angles. We probably want to use given information. So if I look A and C, what's the relationship between A and C to angle A? A is opposite. So I should write sine of angle A is equal to A divided by C. Okay, now to find that angle, we have to use inverse trigonometric ratios. So the inverses are above, and we've used these in the past, so, and we talked about this stuff before, but just as a review, the inverse undoes the sine and cosine. So we're looking for an angle, we use the inverses. They're up here, they're second functions. So we're going to take the inverse sine of A divided by C, which is 30.4, divided by 50.2. And that says 37.3 degrees. Okay. Now, I could have used, well, I can use a different ratio for this. Now, since I know side B, I could have used side B in this calculation, but I want to stay with given information. All right, now we can now find angle B by subtracting from 90, or we can find angle B by recognizing, and we're going with given information, that the side that was given to us was side C and side A. So if you look at side B, or angle B, then this is adjacent over hypotenuse, so I would write then the cosine of angle B is adjacent side A divided by hypotenuse side C. And I should have written this over here, that B is equal to the inverse cosine of A divided by C. I should have written in here, and I didn't do it, that A is equal to the inverse sine of A divided by C. I should have shown that. So I stuck it in there. You can see it. All right, so B is equal to, we take the inverse cosine of given information, 30.4 divided by 50.2. And that is 52.7 degrees. Now, what you should find when you do this, since this is a right triangle, is that these two angles should add up to 90 degrees, which they do. If they don't, you need to go back and check what you did and make sure that you have the correct ratios, and that you're using the correct either sine, cosine, or tangent. Identify the sides that you have and identify the angle that you're looking for, and either sine, cosine, or tangent will apply. And remember, for the right triangle trigonometry, the ratios are always SOHCAHTOA. And we have talked about what that means in the past. Okay, well, your assignment for today. We're in section 5.8, and then it begins on page 595. You have numbers 2, 8, and 10. That's it, 3 problems. That should be enough. It's this isn't a grossly difficult subject, and you should be able to handle that relatively easily. Okay, until tomorrow.